your mind, every word a step forward. Let the learning begin. Let the learning begin. Boost your English. Boost your English. B-Y-E. B-Y-E. Welcome to the workshop.
BYE Workshop, Episode 8. Welcome to the 8th session of the BYE Workshop. I am Ryan. If you are looking for comfort or entertainment, you are in the wrong place. This is not a conversation. It is a clinical extraction of linguistic data. We are here to dismantle the English language and replace ambiguity with surgical precision. In this workshop, we do not suggest. We instruct. Your progress depends entirely on your ability to process these facts with absolute focus. Listen closely. There will be no repetitions. Newtonian determinism, the philosophical and mechanical doctrine that every physical event is completely determined by pre-existing causes and strict mathematical laws. For example, classical physics relies entirely on the predictable machinery of Newtonian determinism. Billiard balls, smooth, hard spheres used in the game of billiards, frequently used to exemplify predictable, classical Newtonian collisions. For example, atoms do not behave like miniature billiard balls bouncing off walls. Phase space, an abstract multidimensional space in which all possible states of a classical system are represented, with each state corresponding to a unique point. For example, the trajectory of a classical pendulum is mapped precisely within a two-dimensional phase space. Statistical mechanics, the branch of physics that uses statistical methods to explain the macroscopic properties of large systems based on their microscopic constituents. For example, classical statistical mechanics explains temperature as the average kinetic energy of moving molecules. Deterministic certainty, the condition of complete predictability where the future state of a system is entirely dictated by its current laws and parameters. For example, classical mechanics offered deterministic certainty, which quantum theory thoroughly dismantled. Epistemological rupture, a fundamental breakthrough or shift that completely shatters and replaces established ways of acquiring and validating knowledge. For example, the transition from classical physics to quantum mechanics represents a massive epistemological rupture. Subatomic realm, the physical domain of matter and energy at scales smaller than an atom, where quantum mechanics dominates. For example, classical laws of motion fail completely when applied to the subatomic realm. Quantum regime, the specific physical scale or set of conditions where quantum mechanical effects become observable and dominant. For example, supercooling the material allowed researchers to observe physics within the quantum regime. Planck scale, the ultimate physical limit of length, time, and mass, below which classical notions of space and gravity completely break down. For example, quantum gravitational effects become dominant only when exploring the Planck scale. Granularity, the scale of detail or the presence of discrete, fundamental units within a structure or system. For example, the smooth appearance of classical spacetime disappears into quantum granularity at the smallest scales. Wave-particle duality, the fundamental quantum concept that every entity exhibits both wave-like and particle-like properties. For example, light demonstrates wave-particle duality when it produces interference patterns yet registers as localized impacts. De Broglie relation, the fundamental equation relating the wavelength of a matter wave to the momentum of its corresponding particle. For example, the dual nature of moving matter is calculated precisely via the de Broglie relation. Wavelength, the physical distance between successive crests or identical points of a wave. For example, decreasing the momentum of an electron increases its corresponding quantum wavelength. Inversely proportional, a mathematical relationship where one value decreases at the same rate that another value increases. For example, the wavelength of a moving particle is inversely proportional to its momentum. Plane waves, idealized, infinite waves whose wavefronts are parallel planes of constant amplitude perpendicular to the direction of travel. For example, a particle with a perfectly defined momentum is represented mathematically by plane waves. Fourier analysis, a mathematical method used to decompose a continuous function into a sum of simpler sine and cosine waves. For example, we determine the momentum components of a spatial wave function by performing a Fourier analysis. Constructive and destructive interference, the phenomenon where waves combine to either reinforce or cancel each other out based on their phase relationship. For example, the bright and dark bands on the screen result directly from constructive and destructive interference. Physically smeared, existing in a diffuse, non-localized, or extended state across a region of space rather than at a single point. For example, before detection, the electron's position is physically smeared across the entire atomic orbital. Ontologically undefined, lacking a definite, real existence or objective state of being prior to observation. For example, the position of an unobserved photon is ontologically undefined within standard quantum theory. Fundamental indeterminacy, the intrinsic, irreducible lack of precise physical values in a quantum system prior to measurement. For example, the experiment proved that the position of an electron is governed by fundamental indeterminacy. Unbounded indeterminacy, a state of completely infinite, unlimited uncertainty regarding a physical value. For example, measuring the exact position of a particle induces an unbounded indeterminacy in its momentum. Heisenberg's uncertainty principle, a fundamental mathematical law stating that certain pairs of physical properties cannot be simultaneously known with absolute precision. For example, measuring momentum with perfect accuracy triggers Heisenberg's uncertainty principle, leaving position completely unknown. Conjugate variables, a pair of physical variables that are mathematically related via Fourier transforms and limited by the uncertainty principle. For example, energy and time form a pair of conjugate variables in quantum field dynamics. Non-commuting mathematical operators, operators where the order of multiplication alters the final result, meaning AB does not equal BA. For example, position and momentum are represented by non-commuting mathematical operators. Mathematical commutator, an operator expression defined as AB minus BA, which measures the degree to which two operators fail to commute. For example, the value of the mathematical commutator for position and momentum is equal to I times the reduced Planck constant. Reverse order, the exact opposite sequence of a given arrangement or operation. For example, multiplying matrix A by matrix B yields a different result if you perform the operation in reverse order. Artifact, a spurious, artificial effect or error resulting from the technology or method used, rather than a true physical property. For example, the blurred image was not a physical feature but an artifact of the detector's low resolution. Formalism of quantum mechanics, the mathematical structure, including vectors, operators, and Hilbert spaces, used to formulate the laws of quantum physics. For example, predictable physical results are derived directly from the mathematical formalism of quantum mechanics. Mathematical abstraction, a conceptual model or representation stripped of physical materiality, existing purely as a formal mathematical entity. For example, a vector space is a mathematical abstraction used to organize physical observables. Field of complex numbers, the mathematical domain consisting of all numbers of the form a plus bi, where I is the imaginary unit. For example, the state vectors of quantum mechanics are defined strictly over the field of complex numbers. Greek letter psi, the standard mathematical symbol, written as psi or psi, used to denote the wave function in quantum mechanics. For example, the evolution of the Greek letter psi is dictated by the fundamental wave equation. Complex-valued probability amplitude, a number containing both a real and an imaginary part whose magnitude represents a likelihood value within quantum mechanics. For example, each point in space is assigned a complex-valued probability amplitude. Probability amplitudes, complex numbers used in quantum mechanics to describe the behavior of physical systems, whose absolute square yields a probability density. For example, physical predictions rely on calculating probability amplitudes before any measurement occurs. Probability density, a mathematical function that describes the relative likelihood for a continuous random variable to take on a given value at any point. For example, the absolute square of the wave function yields the spatial probability density of the particle. Absolute square, the product of a complex number and its complex conjugate, resulting in a non-negative real number. For example, to convert a complex amplitude into a real probability, you must calculate its absolute square. Born rule, the fundamental postulate of quantum mechanics that gives the probability that a measurement on a quantum system will yield a given result. For example, the connection between mathematical wave functions and actual experimental data is provided by the Born rule. Exhaustively encapsulated, completely, thoroughly, and perfectly contained within a specific description or boundary. For example, all accessible physical information about the system is exhaustively encapsulated within its wave function. Quantum states, the mathematical description of the physical condition of a quantum system, containing all accessible information about it. For example, measuring the particle causes an immediate transition between distinct quantum states. Conceivable physical state, any configuration or condition of a physical system that is theoretically allowed by the laws of physics. For example, the Hilbert space contains a unique vector for every conceivable physical state. State vector, a mathematical vector that fully represents the configuration of a quantum system within a vector space. For example, the time evolution of a system is tracked by observing the rotation of its state vector. Unit vector, a vector with a mathematical length or norm exactly equal to 1, used to ensure total probability equals 100%. For example, a valid quantum state must always be represented by a normalized unit vector. Hilbert space, an abstract, infinite-dimensional vector space possessing the structure of an inner product, used to define all possible quantum states. For example, every physically realizable state vector exists as a point within a specific Hilbert space. Infinite dimensional vector space, a continuous vector space requiring an infinite number of basis vectors to span its entire domain, such as a Hilbert space. For example, continuous particle positions must be modeled within an infinite dimensional vector space. Orthogonal basis vectors, a set of mutually perpendicular vectors of unit length used to define a coordinate system or state space. For example, the distinct physical outcomes of an experiment correspond to orthogonal basis vectors. Linear differential equations, equations involving derivatives where the unknown function and its derivatives appear to the first power and are never multiplied together. For example, the principles of superposition apply directly because the governing equations are linear differential equations. Partial differential equation, a differential equation that contains unknown multivariable functions and their partial derivatives. For example, the fundamental wave equation of physics is structured as a complex partial differential equation. Time derivative, the rate at which a specific physical quantity changes with respect to time. For example, the Schrödinger equation equates the time derivative of the wave function to the system's total energy. Hamiltonian operator, the mathematical operator corresponding to the total energy of a quantum system, including both motion and potential energy. For example, to determine how a system evolves, you must first construct its specific Hamiltonian operator. Kinetic and potential energy. Kinetic energy is the energy of motion, while potential energy is the stored energy of position or configuration. For example, the total classical energy is found by summing the kinetic and potential energy. Schrödinger equation, the fundamental partial differential equation that governs the time evolution of a non-relativistic quantum system's wave function. For example, the behavior of an isolated electron is calculated using the time-dependent Schrödinger equation. Continuous, deterministic propagation, the smooth, uninterrupted, and predictable spread or development of a wave through space and time. For example, the unobserved wave function exhibits continuous, deterministic propagation. Deterministic evolution, the smooth, predictable development of a physical state over time according to a strict mathematical law. For example, between measurements, the quantum state vector undergoes a completely deterministic evolution. Global wave function, the comprehensive wave function that describes the entire universe or the totality of an extended composite system. For example, the evolution of the universe is described mathematically by a single global wave function. Linear combination, a mathematical expression formed by multiplying each term by a constant and adding the results together. For example, the total wave function is expressed as a linear combination of its permissible states. Coherent superposition, a state in which a quantum system exists simultaneously in multiple potential physical configurations until an external measurement occurs. For example, the qubit remains in a coherent superposition of both binary values during computation. Flat, infinite distribution, a probability distribution that spreads evenly across all space without any peaks or boundaries. For example, a perfectly localized momentum state corresponds to a flat, infinite distribution of spatial probabilities. Probability distribution, a mathematical function providing the probabilities of occurrence of different possible outcomes in an experiment. For example, the repeated trials mapped out a perfect Gaussian probability distribution. Infinitesimal, infinitely narrow spike, an infinitely small quantity, or a mathematical function that is zero everywhere except at a single point where it is infinite. For example, a precise position measurement collapses the wave function into an infinitely narrow spike. Permissible eigenstates, the specific, mathematically allowed states that a quantum system can collapse into during a measurement. For example, the system must select one of the permissible eigenstates when an observation occurs. Eigenstate, a specific, definite state of a quantum system that corresponds to a fixed, measurable value of a physical observable. For example, after measurement, the particle is guaranteed to reside in an eigenstate of that specific operator. Mutually exclusive possibilities, a set of events or states where the occurrence of one completely precludes the simultaneous occurrence of the other. For example, being spin up or spin down are mutually exclusive possibilities for a single measurement axis. Spin up, spin down, the two opposing discrete orientations of a particle's intrinsic angular momentum along a chosen measurement axis. For example, the magnetic field deflected the electron beam into two distinct paths, corresponding to spin up and spin down. Spin-half particles, elementary particles, such as electrons and quarks, that possess an intrinsic angular momentum equal to half of the reduced Planck constant. For example, the behavior of matter is governed fundamentally by the exclusion principle acting on spin-half particles. Total spin, the combined intrinsic angular momentum of all constituent particles within a quantum system. For example, the total spin of the combined system must equal zero to maintain symmetry. Conservation of angular momentum, a fundamental physical law stating that the total rotational momentum of an isolated system remains constant. For example, the direction of the second particle's spin is guaranteed by the conservation of angular momentum. Singlet state, a quantum state of a multiparticle system where the total angular momentum is zero, characterized by perfect anticorrelation. For example, two entangled electrons often reside in a stable, zero-spin singlet state. Anticorrelation, a relationship between two variables where a high value in one corresponds strictly to a low or opposing value in the other. For example, when two particles are in a singlet state, their spins exhibit perfect anticorrelation. Bipartite system, a physical or mathematical system composed of exactly two distinct interacting parts or subsystems. For example, the experiment analyzed the correlation between two photons in a simple bipartite system. Composite system, a quantum system consisting of two or more distinct subsystems. For example, the total angular momentum of a composite system is determined by combining individual particle spins. Tensor product, a mathematical operation used to combine independent vector spaces into a single, comprehensive vector space representing a composite system. For example, the state space of two separate particles is constructed using a tensor product. For example, the state space of two separate particles is constructed using a tensor product. Multiplicative explosion, a massive, exponential increase in mathematical dimensions or computational complexity resulting from combining multiple variables. For example, adding more particles to a quantum simulation causes a multiplicative explosion of the required Hilbert space. Non-separable wave function, a wave function of a multiparticle system that cannot be mathematically factored into a product of single-particle wave functions. For example, an entangled state is defined precisely by a non-separable wave function. Entanglement, a quantum phenomenon where two or more particles become interconnected so that the state of one instantly dictates the state of the other, regardless of distance. For example, two photons exhibit perfect correlation when they undergo quantum entanglement. Holistic, characterized by the belief that the parts of something are intimately interconnected and can only be understood by reference to the whole. For example, entanglement forces a holistic view of composite systems where individual identities dissolve. Spooky action at a distance, the historical, derogatory term used to describe the instantaneous, non-local connection between entangled quantum particles. For example, Albert Einstein rejected the implications of quantum mechanics, famously calling non-locality spooky action at a distance. EPR paradox, a seminal thought experiment proposed by Einstein, Podolsky, and Rosen, arguing that quantum mechanics is incomplete because it implies non-local reality. For example, the modern understanding of entanglement emerged directly from investigations into the EPR paradox. Local realism, the classical principle that physical objects possess definite properties independent of measurement, and that physical influences cannot travel faster than light. For example, the experimental violation of Bell inequalities definitively disproved local realism. Hidden variables, hypothetical, underlying local parameters that classical physicists propose to explain quantum probabilities deterministically. For example, Bell proved that no local theory of hidden variables can reproduce the predictions of quantum mechanics. Instruction set, a hypothetical list of predetermined outcomes carried by a particle that tells it exactly how to respond to any given measurement. For example, local realism assumes that each particle contains a hidden instruction set prior to detection. Hidden variable ledger, a metaphorical or theoretical record that predetermines the physical values of a particle's properties before an observation occurs. For example, the experiment proved that nature does not maintain a local hidden variable ledger. Combinatorial logic, a type of digital or mathematical logic where outputs are determined solely by the current combination of inputs, without memory. For example, the limits of local realism are derived using straightforward combinatorial logic. Fundamental set theory, the foundational branch of mathematics that studies collections of objects, defining basic logical operations and boundaries. For example, the proof of Bell's theorem relies on the basic laws of fundamental set theory. Mathematical upper limit, the highest possible value that a mathematical expression or statistical correlation can legally achieve under specific constraints. For example, quantum mechanics systematically exceeds the mathematical upper limit imposed by classical local realism. Bell's inequality, Bell's theorem, a mathematical theorem proving that no physical theory of local hidden variables can reproduce all the statistical predictions of quantum mechanics. For example, the experimental violation of Bell's inequality confirmed that nature is fundamentally non-local. Bipartite entangled systems, quantum setups consisting of two separated, interconnected subsystems used to test non-local correlations. For example, researchers measured spin correlations using bipartite entangled systems. Spatial separation, the physical distance between two distinct entities or events in spacetime. For example, the two entangled electrons maintained their correlation despite a vast spatial separation. Isolated physical systems, a completely enclosed physical domain that does not exchange energy, matter, or information with its external environment. For example, a perfect quantum computer must behave as an isolated physical system to prevent errors. Intervening space, the physical region of spacetime that separates two distinct objects or events. For example, the quantum correlation persisted without any physical medium crossing the intervening space. In zero time, instantaneously, without any duration or chronological delay. For example, the change in the entangled partner occurred in zero time across the laboratory. Time delay, the measurable duration of time between an action and its subsequent reaction or detection. For example, the ultra-fast sensors confirmed there was absolutely no time delay between the two quantum events. Physical signal, a transmission of energy or matter that conveys measurable information from one point to another. For example, no physical signal can travel between the two detectors faster than light. Relativistic speed limit, the absolute cosmic speed limit dictated by special relativity, stating that no information or matter can travel faster than the speed of light. For example, quantum non-locality does not violate the relativistic speed limit because it cannot transmit messages. Physical correlation, a systematic, observable connection or statistical dependence between the physical properties of separate systems. For example, the data confirmed a strict physical correlation between the two distant detectors. Non-local correlation, a statistical connection between distant physical systems that cannot be explained by any local mechanisms or subluminal signals. For example, the experiment demonstrated a non-local correlation that defied classical physics. Divergent statistical reality, a situation where two different theoretical frameworks predict completely irreconcilable sets of statistical data. For example, the experimental results confirmed the divergent statistical reality predicted by quantum mechanics. Misaligned measurement axes, the deliberate geometric offset between the orientations of two distant detecting devices. For example, the non-classical statistical correlations appear most clearly when using misaligned measurement axes. Measurement axis, the specific spatial direction along which a measuring device is oriented to determine a particle's physical property. For example, changing the orientation of the measurement axis alters the observed probability distribution. Configuration, the specific spatial or physical arrangement of parts within a system. For example, the experimental apparatus required a highly precise geometric configuration to detect the particles. Trigonometric relationship, a mathematical connection based on the properties of triangles and angles, such as sine and cosine functions. For example, the classical linear prediction fails because quantum correlations follow a strict trigonometric relationship. Cosine squared, a trigonometric function representing the square of the cosine of an angle, which dictates the probability of spin correlations. For example, the alignment of the filters determines the transmission rate according to a cosine squared relationship. Ceilings, the maximum upper limits placed on a physical or mathematical value. For example, the experiment pushed the statistical correlations up to their absolute theoretical ceilings. Discrepancies, logical or statistical differences between two or more sets of facts or data. For example, the analysis revealed clear discrepancies between classical predictions and quantum data. Battle lines, the metaphorical boundaries or positions defining an intense disagreement or conflict. For example, the battle lines between Einstein and Bohr were drawn over the completeness of quantum theory. Photon pairs, two photons generated simultaneously from a single source, typically sharing an entangled quantum state. For example, the laboratory produced entangled photon pairs using a specialized nonlinear crystal. In mid-flight, while an object or signal is moving through space between its origin and its destination, for example, the measurement orientation was altered while the photon was in mid-flight. Ultra-high-speed acousto-optic switches, devices that use sound waves to rapidly alter the path or properties of light within nanoseconds. For example, to ensure causal isolation, the researchers utilized ultra-high-speed acousto-optic switches. Subluminal communication signal, any data transmission that travels slower than the speed of light through a medium. For example, a subluminal communication signal would arrive far too late to influence the distant detector. Optical detectors, highly sensitive electronic devices designed to intercept, record, and measure individual units of light. For example, the photon impacts were recorded by high-efficiency optical detectors. High-velocity trials, experimental runs conducted at extreme speeds to isolate events and prevent causal communication. For example, the hypothesis was rigorously tested through a series of automated, high-velocity trials. Loophole-free experiments, advanced physical tests designed to eliminate all potential experimental errors or alternative explanations, such as communication or detection flaws. For example, the non-local nature of reality was definitively proven by loophole-free experiments. Flagrantly, repeatedly, and consistently violate, to break a rule, law, or mathematical limit openly, multiple times, and with absolute regularity. For example, the experimental datasets flagrantly, repeatedly, and consistently violate the classical Bell inequalities. Measurement problem, the unresolved paradox in quantum mechanics regarding how and why a continuous quantum superposition collapses into a single classical outcome upon observation. For example, the measurement problem remains one of the most intensely debated topics in modern physics. Macroscopic apparatus, a large, classical measuring device or environment used to detect and record quantum events. For example, the subtle state of the atom was permanently recorded when it interacted with a macroscopic apparatus. Catastrophic intervention, a severe, disruptive action that completely alters or destroys the original state of a delicate system. For example, a physical measurement constitutes a catastrophic intervention that destroys quantum superposition. Collapse, the sudden, non-linear reduction of a quantum superposition into a single definite eigenstate due to measurement. For example, the wave function underwent an instantaneous collapse the moment the detector registered a signal. Projection postulate, the mathematical assumption that a measurement causes a quantum state to instantly project onto an eigenstate of the measured operator. For example, the sudden change of the wave function is handled mathematically via the projection postulate. Abrupt, non-linear projection, a sudden mathematical or physical change that forces a vector onto a specific axis, violating smooth linear progression. For example, the standard Copenhagen model relies on an abrupt, non-linear projection during measurement. Smoothly propagating, advancing through space and time in a continuous, uninterrupted, and fluid manner without abrupt shifts. For example, the unobserved wave function is modeled as a smoothly propagating field. Discontinuously collapses, abruptly and instantaneously transitions from a broad superposition into a single discrete state without passing through intermediate states. For example, upon striking the screen, the extended wave function discontinuously collapses into a single dot. Orthodox Copenhagen interpretation, the traditional understanding of quantum mechanics developed by Niels Bohr and Werner Heisenberg, asserting that physical systems only have probabilities until measured. For example, the orthodox Copenhagen interpretation avoids explaining the exact physical mechanism of wave function collapse. Epistemological firewall, a conceptual barrier erected to separate what can be known from what cannot, or to isolate two conflicting domains of theory. For example, the Copenhagen model creates an epistemological firewall between the quantum observer and the classical system. Epistemological dualism, a philosophical framework that divides reality into two separate systems or modes of knowledge. For example, the separation of the universe into quantum systems and classical observers represents an unsustainable epistemological dualism. Microscopic quantum realm, the hidden domain of individual atoms and subatomic particles governed strictly by quantum mechanics. For example, classical logic fails entirely when entering the microscopic quantum realm. Computational tool, a mathematical method, algorithm, or model used to calculate practical results without necessarily describing objective physical reality. For example, many physicists treat the wave function purely as a convenient computational tool. Philosophical schism, a deep, fundamental division between opposing factions based on conflicting beliefs or interpretations. For example, the debate over the nature of reality created a permanent philosophical schism among foundational physicists. Theoretical metaphysics, speculative philosophy that deals with the first principles of things, including abstract concepts such as being and knowing, that cannot be directly tested. For example, arguments about unobservable universes belong to the realm of theoretical metaphysics. Untestable, incapable of being proven true or false through empirical observation or physical experimentation. For example, an interpretation that yields no unique experimental predictions is scientifically untestable. Interpretational preference, a subjective or philosophical choice made between multiple scientifically valid explanations of the same data. For example, choosing between many worlds and collapse models is currently a matter of interpretational preference. Epistemological stalemate, a situation where further progress in knowledge is blocked because multiple theories explain the same data perfectly without any means of differentiation. For example, the debate over quantum interpretation has reached an epistemological stalemate. Quantum decoherence, the physical process by which a quantum system loses its phase relationships and superposition due to interaction with its surrounding environment. For example, a quantum computer must be carefully shielded to prevent destructive quantum decoherence. Measuring device, an instrument or apparatus used to quantify or record a physical property of a system. For example, the interaction with the macroscopic measuring device rapidly destroys the subtle quantum coherence of the system. Superconducting circuits, electrical circuits made of materials that exhibit zero electrical resistance, capable of maintaining macroscopic quantum states. For example, the engineers designed a quantum processor utilizing highly sensitive superconducting circuits. Chaotic, thermodynamic monstrosity, a derogatory physical description of a massive, uncoordinated macroscopic system containing endless random energy exchanges and particles. For example, from a quantum perspective, a room temperature laboratory is a chaotic, thermodynamic monstrosity. Trillions of violently interacting atoms, a phrase describing the dense, turbulent atomic composition of classical macroscopic objects. For example, a delicate superposition cannot survive contact with trillions of violently interacting atoms. Infinite thermodynamic sink, an environmental system so large that it can absorb an endless amount of energy or phase information without changing its own macroscopic state. For example, the surrounding atmosphere acts as an infinite thermodynamic sink for quantum phase information. Degrees of freedom, the independent parameters or coordinates required to completely define the physical state of a system. For example, a macroscopic object possesses a near-infinite number of microscopic degrees of freedom. Phase relationships, the precise alignment and timing between different components of a wave function that allow for interference patterns. For example, coherent quantum computing depends entirely on maintaining exact phase relationships. Interference terms, the mathematical cross-terms in a quantum state's density matrix that represent the physical presence of superposition. For example, environmental interaction causes the vital interference terms to vanish from the equations. Scrambled, confused, mixed up, or randomized so that the original orderly structure or information is completely lost. For example, the coherent phase information was completely scrambled by random collisions with gas molecules. Density matrix, a mathematical matrix that describes the statistical state, both quantum and classical, of a physical system. For example, we track the transition from a pure state to a mixture by analyzing the evolution of the density matrix. Off-diagonal elements, the specific components of a density matrix that quantify the level of quantum superposition between different states. For example, the onset of decoherence causes the off-diagonal element of the matrix to rapidly decay. Exponentially decay to zero, to diminish at a rate proportional to its current value, rapidly approaching absolute zero. For example, the quantum coherence terms exponentially decay to zero within a fraction of a microsecond. Mixed state, a statistical mixture of distinct quantum states where true quantum superposition has been replaced by classical probability. For example, after decoherence, the system can only be described as a classical mixed state. Singular outcomes, individual, definite physical results that occur to the exclusion of all other potential options. For example, the classical world is characterized by singular outcomes rather than persistent superpositions. Feline, relating to or affecting cats, a direct reference to Erwin Schrödinger's famous thought experiment involving a cat. For example, the paradox explores the absurd macroscopic consequences of a feline existing in a superposition of life and death. Conscious entity, a being possessing awareness, perception, and subjective experience. For example, Wiener suggested that a conscious entity is required to finally trigger the collapse of a wave function. Everettian many-worlds formulation, an interpretation of quantum mechanics stating that the wave function never collapses, and that all possible outcomes occur in branching, parallel universes. For example, the Everettian many-worlds formulation eliminates the need for an abrupt, non-physical collapse postulate. Universally valid, true, applicable, and operational at all times, across all scales, and under all conceivable conditions. For example, in the many-worlds theory, the Schrödinger equation is assumed to be universally valid. Bifurcates to splitting, divides or separates into two distinct branches or paths. For example, the universe effectively bifurcates every time a quantum measurement occurs. Iteration, the repetition of a process or mathematical procedure to generate successive outcomes. For example, each iteration of the experiment creates new branches of reality. Newly minted branch, a freshly created parallel universe or timeline resulting from a quantum bifurcation event. For example, an observer in each newly minted branch perceives only a single, definite experimental outcome. Mutually inaccessible, strictly orthogonal branches, separate paths or realities within a multi-universe structure that can never interact or influence each other. For example, the different experimental outcomes exist in mutually inaccessible, strictly orthogonal branches of the total wave function. Universal Hilbert space, the all-encompassing, infinite-dimensional vector space that contains the complete state vector of the entire multiverse. For example, every parallel universe exists as a subvector within the universal Hilbert space. Deterministic purity, the pristine condition of complete mathematical predictability and lawfulness, entirely free from random or arbitrary collapses. For example, many physicists favor the many-worlds model because it restores deterministic purity to quantum theory. Multiverse, the hypothetical collection of all possible universes or parallel realities operating under consistent physical laws. For example, the concept of the multiverse emerges naturally if you refuse to truncate the wave function. Non-relativistic quantum mechanics, the basic framework of quantum physics that does not incorporate Einstein's special relativity, valid only for low speeds and fixed particle numbers. For example, the Schrödinger equation is the core equation of non-relativistic quantum mechanics. Quantum field theory, the advanced theoretical framework combining quantum mechanics, special relativity, and classical field theory to describe particle interactions and creation events. For example, the modern understanding of fundamental forces is formulated strictly within quantum field theory. Desolate void, a completely empty, barren, and vacant space. For example, in quantum field theory, space is never a desolate void, it is filled with fluctuating fields. Transient energy ripples, short-lived, temporary fluctuations or waves that pass through a physical field. For example, empty space is continuously populated by transient energy ripples appearing and disappearing. Quantized excitations, discrete, measurable packets of energy or particles arising from the vibration of an underlying field. For example, photons are simply the quantized excitations of the electromagnetic field. Creation and annihilation, the physical processes by which particles are brought into existence or completely destroyed through energy transformations. For example, high-energy collisions result in the constant creation and annihilation of subatomic particles. Standard Model of Particle Physics, the comprehensive theoretical framework that describes 3 of the 4 fundamental forces and classifies all known elementary particles. For example, every experimental particle discovery over the past 50 years has validated the Standard Model of Particle Physics. Lagrangian density, a mathematical function that encapsulates the complete kinetic, potential, and interaction energies of a field system per unit volume. For example, the dynamics of all elementary particles are derived by varying the total Lagrangian density. Symmetry groups, SU, 3, XSU, 2, XU, 1, the mathematical structures that define the specific internal local symmetries and force structures of the Standard Model. For example, the entire architecture of modern particle physics is determined by the combined symmetry groups, SU, 3, XSU, 2, XU, 1. Local gauge invariance, the property where the fundamental equations remain completely unchanged under localized internal transformations that vary across space and time. For example, demanding local gauge invariance automatically dictates the existence of force-carrying fields. Non-abelian gauge theory, a mathematical quantum field theory where the order of successive local transformations affects the final outcome, forming the basis of nuclear forces. For example, the strong interaction is described by a non-abelian gauge theory known as quantum chromodynamics. Quarks and leptons, the 2 fundamental families of elementary spin-half matter particles that constitute all known physical objects. For example, quarks experience the strong nuclear force, whereas leptons do not. Chiral nature, the fundamental property of particles where their spin orientation relative to their direction of motion makes them inherently left-handed or right-hand. For example, the weak force interacts exclusively with left-handed matter, highlighting the chiral nature of modern physics. Chiral spinous, mathematical vector entities used to describe fermions with a definite handedness or chirality in relativistic quantum mechanics. For example, left-handed electrons are modeled as chiral spinous that transform uniquely under weak interactions. Weak isospin gauge group, the specific mathematical symmetry group, denoted as SU, 2, that governs the behavior of particles experiencing the weak nuclear force. For example, only left-handed fields carry a charge under the weak isospin gauge group. Explicit mass terms, direct mathematical values representing particle mass inserted into a Lagrangian equation, which often break required symmetries. For example, adding explicit mass terms directly to the equations destroys the mathematical consistency of the electroweak theory. UN renormalizable, a catastrophic condition in a quantum field theory where mathematical calculations yield infinite values that cannot be eliminated by standard techniques. For example, a theory with explicit mass terms inserted arbitrarily becomes completely UN renormalizable. Lack inertia, to completely possess zero mass or resistance to acceleration, forcing the particle to travel permanently at the speed of light. For example, without an external mechanism, all fundamental fermions would lack inertia entirely. Brout-Englert-Higgs mechanism, the theoretical physical process whereby gauge bosons and fermions acquire mass through spontaneous symmetry breaking in a background scalar field. For example, the structural consistency of the Standard Model is preserved entirely by the Brout-Englert-Higgs mechanism. Paradigm-shifting formulation, a revolutionary mathematical or conceptual structure that completely changes established scientific models. For example, the introduction of the scalar field was a paradigm-shifting formulation that resolved the problem of particle mass. Ubiquitous constituent, an element or entity that is present everywhere simultaneously throughout the entire universe. For example, the Higgs field is a ubiquitous constituent of space, permeating every single cubic centimeter of the cosmos. Background field, a continuous, pervasive field that exists throughout space, acting as a constant medium for other interacting particles. For example, moving particles experience a drag-like effect through their constant interaction with the background field. Complex scalar fields, fields that are defined by a complex number at each point in spacetime and possess no intrinsic angular momentum or spin. For example, the Higgs mechanism utilizes a pair of complex scalar fields to generate mass. Self-interaction potential, the potential energy of a field that depends directly on its own value or configuration, dictating how it behaves in isolation. For example, the stability of the vacuum state is determined by the field's specific self-interaction potential. Mexican hat potential, the descriptive name given to the shape of a potential energy graph that possesses a central local maximum and an infinite ring of degenerate minimal energy states. For example, the symmetry of the system is broken because the field rolls down the slopes of a Mexican hat potential. Symmetrical configuration, an arrangement where all parts or fields balance perfectly around a central point, showing no preferred direction or value. For example, the scalar field initially resided in an unstable but perfectly symmetrical configuration. Potential gradient, the rate and direction of change in potential energy across a given space or field value. For example, the field rolled rapidly down the potential gradient toward a lower energy level. Nascent universe, the newly born, infant universe during the earliest, highest energy fractions of a second following the Big Bang. For example, the background field underwent a critical transformation during the cooling of the nascent universe. Electroweak symmetry, the unified state of physics where the electromagnetic force and the weak nuclear force operate as a single, indistinguishable interaction. For example, high temperatures are required to maintain electroweak symmetry in a physical system. To generate minimal energy states, a set of multiple, distinct lowest energy configurations that all share the exact same minimum energy value. For example, the base of the potential energy curve consists of a continuous ring of degenerate minimal energy states. Cosmological phase transition, a massive, universe-wide structural transformation that occurs when the cosmos cools past a critical temperature threshold. For example, the separation of forces was driven by a violent cosmological phase transition. Spontaneous symmetry breaking, the physical process where a system that is symmetric under a set of laws settles into an asymmetric state, choosing a specific orientation or value. For example, the acquisition of mass is a direct consequence of spontaneous symmetry breaking. Vacuum expectation value, the non-zero average value that a quantum field possesses when it resides in its lowest possible energy state or vacuum. For example, the Higgs field possesses a non-zero vacuum expectation value throughout all empty space. Gigaelectronvolts, a standard high-energy unit of measurement equal to 1 billion electronvolts, used to quantify subatomic mass and energy scales. For example, the vacuum expectation value of the Higgs field is approximately 246 gigaelectronvolts. Yukawa couplings, the specific mathematical terms in the Lagrangian that quantify the strength of the interaction between the Higgs field and fundamental fermions, determining their mass. For example, the massive difference in weight between an electron and a top quark is dictated by their unique Yukawa couplings. Gauge bosons, W and Z, the heavy force-carrying particles that mediate the weak nuclear interaction, responsible for radioactive decay. For example, the discovery of the massive gauge bosons, W and Z, confirmed the validity of the electroweak unification. Goldstone bosons, massless, spinless particles that automatically appear whenever a continuous global symmetry is spontaneously broken. For example, the unwanted Goldstone bosons are mathematically absorbed to give mass to the force carriers. Longitudinal polarization states, the third orientation of a vector particle's vibration that is parallel to its direction of motion, which is only possible for particles with mass. For example, massless photons possess only transverse polarizations, whereas massive W bosons acquire longitudinal polarization states. Vector particles, force-carrying particles with an intrinsic spin equal to 1, such as photons and gluons. For example, the weak interaction is mediated by heavy vector particles. Unabsorbed radial degree of freedom, the single remaining physical component of the broken scalar field that does not get consumed to provide mass to gauge bosons. For example, the physical Higgs boson is the material manifestation of this unabsorbed radial degree of freedom. Higgs boson, the heavy scalar elementary particle discovered at CERN in 2012, confirming the existence of the mass generation field. For example, the decay channels of the Higgs boson were analyzed using advanced particle accelerators. Utilitarian manifestation, a highly practical, functional, and useful real-world application of an abstract scientific theory. For example, medical imaging stands as a prime utilitarian manifestation of advanced quantum field principles. Positron emission tomography, PET scan, an advanced, non-invasive nuclear medicine imaging technique that detects gamma rays emitted by a positron-emitting radionuclide to map metabolic activity. For example, the physician ordered a positron emission tomography scan to locate the patient's tumor. Oncological diagnostic tool, a specialized medical instrument, technology, or method used to identify, evaluate, and track cancerous growths within the body. For example, positron imaging is an invaluable oncological diagnostic tool. Tracer molecule, fluorodeoxyglucose, a modified sugar molecule labeled with a radioactive atom, used to visualize glucose metabolism in living tissues. For example, malignant tumors consume vast quantities of the tracer molecule fluorodeoxyglucose. Targeted biological payload, a specific chemical or molecular compound engineered to deliver a medical tracking agent directly to specific diseased cells. For example, the radioactive isotope was attached to a targeted biological payload. Radioactive payload, the specific quantity of unstable, emitting material carried by a tracer molecule for tracking purposes. For example, the cells were destroyed from within by the localized delivery of a radioactive payload. Radioisotope, fluorine-18, an unstable, radioactive form of an element that decays by emitting radiation, used extensively as a medical tracer. For example, the diagnostic fluid relies on the short half-life of the radioisotope fluorine-18. Beta plus decay, a specific type of radioactive decay where a proton inside a radionuclide transforms into a neutron, emitting a positron and an electron neutrino. For example, the tracer undergoes beta plus decay inside the patient's body. Transmutation, the changing of one chemical element or isotope into another through a nuclear reaction or radioactive decay. For example, the emission of a positron causes the structural transmutation of fluorine into stable oxygen. Electron neutrino, an elementary, nearly massless lepton emitted during beta plus decay that interacts via the weak nuclear force. For example, the electron neutrino escapes the body entirely without interacting with the medical detectors. Positron, the antiparticle of the electron, possessing the exact same mass but a positive electrical charge. For example, the emitted positron travels a fraction of a millimeter through tissue before encountering matter. Malignant oncological pathologies, medical conditions characterized by the rapid, uncontrolled, and destructive growth of cancerous tumors. For example, advanced imaging techniques are essential for identifying malignant oncological pathologies. Cellular proliferation, the rapid and continuous replication and growth of cell populations. For example, high metabolic activity is a direct consequence of rapid cellular proliferation. Cancerous lesions, areas of abnormal, damaged, or malignant tissue caused directly by oncological disease. For example, the high-resolution scan revealed multiple small cancerous lesions throughout the liver. Benign tissue, non-cancerous, healthy tissue that grows normally and does not invade surrounding body structures. For example, the diagnostic scan clearly distinguished the tumor from the surrounding benign tissue. Metabolic malignancy, a cancerous condition characterized by extreme, abnormal rates of energy consumption and growth. For example, the high density of gamma-ray lines confirmed the presence of a metabolic malignancy. Inelastic Coulomb collisions, collisions between charged particles where kinetic energy is lost to atomic excitation or ionization via electrostatic forces. For example, the high-speed positron loses its initial kinetic energy through thousands of inelastic Coulomb collisions. Thermal equilibrium, a state where a particle has slowed down sufficiently to match the average kinetic energy of the surrounding molecules. For example, the positron slows to thermal equilibrium before undergoing annihilation. Rest mass, the invariant mass of a physical entity when it is completely stationary relative to an observer. For example, the annihilation event converts the entire rest mass of both particles directly into electromagnetic energy. Mass-energy equivalence principle, the fundamental law of physics, famously stated as E equals mc squared, showing that mass can be converted entirely into energy. For example, the creation of gamma rays from matter is a direct demonstration of the mass-energy equivalence principle. Gamma-ray photons, gamma quanta, high-energy packets of electromagnetic radiation emitted from nuclear reactions or particle annihilation events. For example, the collision of matter and antimatter produces two distinct gamma-ray photons, gamma quanta. Kiloelectronvolts, a unit of energy equal to 1000 electronvolts, used to define the energy levels of X-rays and gamma rays. For example, each annihilation photon possesses an exact energy of 511 kiloelectronvolts. Diametrically opposed trajectories, paths that lead directly away from each other in opposite directions along a single straight line, separated by exactly 180 degrees. For example, momentum conservation forces the two gamma rays to fly off on diametrically opposed trajectories. Scintillating crystal detectors, specialized crystals that emit a brief flash of visible light when struck by high-energy ionizing radiation. For example, the PET scanner ring is lined with hundreds of dense scintillating crystal detectors. Photomultiplier tubes, extremely sensitive vacuum tubes that multiply the electrical signal produced by a faint flash of light, allowing individual photons to be recorded. For example, the weak light from the crystal was amplified instantly by a series of photomultiplier tubes. Coincidence, the simultaneous occurrence of two separate events at different locations within an incredibly narrow, predetermined window of time. For example, the software registers an event only when two opposing sensors record a photon arrival in coincidence. Nanosecond, a unit of time equal to 1/1000th of a second. For example, the coincident circuit operates within a strict time window of less than 10 nanoseconds. Line of response, the calculated straight path connecting two opposing detectors that simultaneously registered an annihilation event. For example, the computer uses thousands of lines of response to map the precise origin of the radiation. Three-dimensional spatial coordinates, a set of three specific values defining the precise position of a point within physical space along the x, y, and z axes. For example, the imaging software calculated the exact three-dimensional spatial coordinates of the malignant tumor. Reverse quantum probability distributions, complex mathematical algorithms used to reconstruct three-dimensional images from raw statistical data collections. For example, the final medical image is computed by applying mathematical models to reverse quantum probability distributions. Critical decoherence, the ultimate, complete loss of quantum phase information that returns a highly complex system back to standard classical behavior. For example, the macro-scale operational mechanics of the PET scan function perfectly because the body's internal environment forces a state of critical decoherence. Ruthless, showing no pity, compromise, or deviation from a strict path. For example, nature enforces its quantum laws with a ruthless, mathematical precision. Jettison, to discard, abandon, or eliminate something that is no longer useful or valid. For example, physicists were forced to jettison classical certainty in favor of statistical probability. The commentary section on our YouTube channel is now open. We require absolute respect and dignity in all your interactions. There will be no tolerance for substandard behavior. Keep boosting your English. Bye for now.